Jai Hind students, let's start the next topic, that is furan. We called it as furon, but the spelling is Furan, but we cannot call it furan, we call it furon. Molecular formula is C4H4O. These are the carbon 1, 2, 3, 4, and these are the hydrogen attached with the carbon 4, and this is the single oxygen, and these all carbon with the oxygen form the 5-membered structure. Oxygen in this having 2 lone pair of electrons. We may be consider it or make it, or we left it, generally write it as this structure. Here is the presence of double bond. Similar structure in the pyrrole, what there is a nitrogen with the hydrogen, but in this there is only oxygen with no hydrogen. So the formula is C4H4O. Molecular structure is this: 5-membered ring in which 4 are carbon and 1 is heteroatom, that is oxygen. And this is aromatic because there is presence of double bond and single bond at an alternative positions. That is, this is the double bond, is this single bond, double bond, single bond, lone pair of electron which is considered as double bond, and then single bond. So it follows the Huckel rule and is aromatic in nature. Next heading is molecular orbital picture diagram of furan. All the carbon atom and oxygen atom in the furan are sp2 hybridized. In the furan there is carbon and oxygen. So carbon in ground state 2s2 and 2p2, but in excited state the s orbital and 2p orbital are hybridized to form hybridized sp2 orbitals with single electrons, and one p orbital are left as unhybridized p orbital with single electron in the carbon excited state. And in oxygen, what happened? Oxygen in ground state, the electronic configuration is 2s2 2p4, but in excited state we consider it in ground state, but we rearranged it the unhybridized orbital in the last p orbital. So 1 s orbital and 2 p orbital are overlapped to form 3 sp2 hybridized orbital, in which the s orbital are having paired electron, p orbital are unpaired electron, that is single electron, and one unhybridized p orbital having paired electron. So this is the specificity of the electrons in the orbitals. So next is carbon has 1 electron each in its 3 sp2 orbitals and one unhybridized p orbital. Carbon, these are 3 hybridized orbital, and this left which is unhybridized p orbital. So all these 3 are sp2 hybridized with single electron, and this unhybridized having single electron. This is written here. Oxygen has 3 sp2 orbital, is this, of which contains 1 electron each, while the third has a pair of electron. The unhybridized p orbital of oxygen also has paired of electron. So what happened, how it forms molecular orbital picture? The carbon uses its sp2 orbital to form carbon carbon, carbon hydrogen, and carbon oxygen bond. I think I should make it in the same carbon, carbon carbon, carbon hydrogen, carbon oxygen bond. carbon, 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 hydrogen, carbon, oxygen, sigma bond, and oxygen uses its 2sp2 orbital to form 2 carbon oxygen sigma bond. Oxygen uses to form its 2 carbon oxygen sigma bond. Next, the unhybridized p orbital of 4 carbon atoms. This is unhybridized p orbital. Unhybridized p orbital, each containing single electron. This is the single electron. Unhybridized p orbital of oxygen. This is unhybridized p orbital of oxygen containing a pair of electron, and together they form pi electron cloud. These pi electron cloud having 6 electron is called aromatic sextate. The unhybridized p orbital of carbon and unhybridized p orbital of oxygen. So carbon uses its this orbital, oxygen uses its this orbital to form aromatic sextate. This is 1 carbon, this is 2 carbon, 3, 4 carbon with the single electrons, and oxygen with its paired electron. They form aromatic sextate because all the electron is equal to 6 electron, which is known as aromatic sextate. Next, the third sp2 orbital of oxygen containing a pair of electron, therefore it cannot participate in formation of aromatic sextate, so it acts as a lone pair of electron. The aromatic sextate, the sp2 orbital, this one of oxygen, which is not involved in formation of aromatic sextate, so it is remain as a lone pair of electron. Here it is mentioned sp2 hybrid orbital of oxygen having lone pair of electrons. So in this structure, this paired electron are used in the formation of aromatic sextate, whereas this is remain as a lone pair of electron. So the function of these two electrons are different. That the first one is used in the formation of aromatic sextate, whereas the second is left as lone pair of electron. Easy. The difference of the two electrons. Next is aromaticity of furan. According to Huckel's rule, 4n plus 2 pi electron rule, it is the presence of these 6 delocalized pi electrons which is responsible for the stability and aromatic character of furan. So it is aromatic because there is presence of 6 pi electron cloud, which is known as aromatic sextate. And here is the 4n plus 2 is equal to 6 electrons, n is equal to 1, which is a non-fractional number, so it is considered as aromatic structure. Next is resonating structure of furan. So this is same. What happens? The lone pair will shift it towards the bond, and the bond will shift it towards the carbon, and then oxygen possesses positive charge because it donates a lone pair, and the lone pair which shifted towards the bond will form new bond, which is double bond, and the bond which is shifted towards the carbon will generate a negative charge. In the next, what happens? These charges, the charge is shifted towards the bond and the bond will shift it towards the carbon. And then what happens? The new bond are formed and the new charges is generated. In the next, these charges will move towards the bond and these bonds are moved towards the carbon. And then there is the formation of new bond and new charges. And next, these charges will shift it towards the bond and this bond will shift it towards the carbon. The next bond and charges are generated. When we further moved it, this will create the first structure. So these 5 are identical in structure. So these are the 5 resonating structure of furan. Benzene is more stable than furan because there is no charge separation is present, so that benzene is more stable. So this is the comparison of furan with the benzene. Benzene, you know what is benzene? 6-membered structure with double single alternative positions of bond is known as benzene. Next is thiophene, which is discussed in the next video. For that, thank you for watching furan. Furan. Thanks, students.